Hello, my name is Isra, and I'm going to be doing chapter 8, problem number 31, and we can just go ahead and start reading the question first. So it says, a weather balloon contains 8.80 moles of helium at a pressure of 0.992 atm and a temperature of 25 degrees Celsius at ground level. What is the volume of the balloon under these conditions? So the first thing I like to do when I look at a problem like this is look at the information that has been given to me. Once I have the information that was given to me, I look at all of that and then basically the units of everything that was given, and based on that I choose whichever formula would work the best. So we have 8.80 moles of helium. Then we're told that it's at a pressure of 0.992 atm. Then we're told that it's at a temperature of 25 degrees Celsius at ground level. And then the other thing we want to look at is, what is the question asking? So it says, what is the volume of the balloon under these conditions? The question asked was, what is the volume? So that's what we're looking for. So let's write down everything that we have. We've got 8.80 moles helium. We've got 0.992 atm. We've got 25 degrees Celsius. And then the volume is what we want to know. Looking at this, I know that moles is mass, atm is in pressure units, and Celsius is in temperature units. And the one that we're trying to look for is volume units. Whatever this is going to be in volume units, which is liters. I mean, it could be in milliliters, but we mostly see that in formulas. Anything that has to do with volume is in liters. So, looking at that information, we've got our mass, our pressure, our temperature, and our volume. I would look at all that, and then I would think about the formulas that we went over when we were learning about gas laws and the gas formulas. And the first thing that comes to my mind is the formula PV equals nRT. Why is that? Because we've got pressure, so that one's done. We've got our mass, that one's done. And then we've got our temperature, that one's done. And we know R is a constant, so that one's done. And the only thing that we're looking for once we check everything off is the volume, and that's exactly what the question wants us to solve for. So this formula would be ideal for this kind of problem. What we could do before we even start plugging everything else in is manipulate this formula so that we're solving for volume. So all we have to do is we want to isolate our volume, so we're going to divide by pressure. These two would cancel out, so then volume equals moles times the constant R times temperature over pressure. Now that we have our manipulated formula that we're going to be plugging everything into, we have to make sure that everything's in the proper units that we will need. So for this specific formula, our mass is going to be in moles, and we can see that the problem already gave us that. It gave us 8.80 moles of helium. So all we're going to have to do with that information is plug it in. So that one is in the form that we need it to be for this formula. The next thing given to us was 0.992 atm, which is in pressure, and that would go over here, and it is in atm, and that's how we want, this formula wants the pressure to be in the units of atm. So that works out. The next one is 25 degrees Celsius, which is our temperature units, and that would go right here, but it is in Celsius, and for this specific formula, they want the temperature to be in Kelvin, so we've got to manipulate that. That one's not good. So let's go over here and write 25 degrees Celsius. This equation, this specific formula wants our temperature to be in Kelvin. So we're going to add 273 and we will get 298 Kelvin. So now we've got that. So we can go ahead and just put that right here and put our check mark here. And the volume is what we're trying to look for in liters. So we've got everything that we need to plug in. So all we have to do now is plug everything in. So our N, which is our moles that we were given in the question, our R, which is a constant, and our T, which is our kelvins that we just converted, all over pressure, which was also given to us, and then we just solve the equation. So let's go ahead and do our multiplication. So once we do the calculation, it equals 217.035 liters. And this would be our volume of our balloon, which is what the question was asking, and that's it. I hope this video helped you guys out. Thank you very much for watching.